paper, it says graphing calculator. It should say basic calculator for tomorrow's part. So make sure you adjust that. Okay, so tomorrow's part of the test, number 1, you need to make sure you know your formulas. Law of sines, law of cosines, and then the 2 area equations. Okay, so if you don't have those, note to self, make sure you know those for tomorrow. You will also be given a blank unit circle. You won't really need it for much tomorrow, but you'll have it both days if you want it. Okay, so tomorrow 7 problems plus your bonus will be on tomorrow's portion, and then the second half of this packet will go through together on Monday for Tuesday's portion of the test. And you guys know you have all those extra practice problems like normal on Polaris. Okay, so there's like 3 of each of these on Polaris for you with solutions. And then tomorrow morning at 7 a.m. I will be here. So if you have any extra questions beyond what we go through in class today and what's posted, you can always pop in tomorrow morning and ask. Okay. All right. Let's get started. Solve triangle ABC, where A is 80, C is 20, and little c is 60. So as always, I'm going to make a sketch to start here. Not drawn to scale. You see? All right, A is 80, C is 20, and then what was little c? 60. Okay. So solve the triangle, which means I'd find everything that's missing. What's the next easiest thing to solve for? Okay, so yeah, either one. So you could get the third angle, which how many degrees do I have right now? 100, so you can do that one mental math, 80. Okay, which actually means I have an isosceles triangle, which is kind of nice. And then you guys were right, you can solve for side A next, and that would give you 2 pairs of opposites. 60 and 20 are a pair, and then 80 and side A are going to be a pair. So what law do I use? Law of sines. And the law of sines is sine of my angle over the side it's opposite. And then again, sine of the angle over the side it's opposite. And then we cross multiply, make sure you are in degree mode, and we'll double check that on the red calculators tomorrow when you get them. 60 sine 80 divided by sine 20. And you will get A equals, we'll round to the nearest tenth here, 172.8, and I'm going to label it meters for this one. Okay. So for this particular problem, yep. For the sides, tenth is good. For the degrees, you can round to the nearest degree, is what we've been doing. But if you don't round to that spot, I won't mark it wrong. Okay. Now for this problem, it's an isosceles triangle, so I actually don't have to solve for the third side. Can you tell me what the third side is? It's also going to be 172.8, but let's say you had different degree measures. You would just use a law of sines again, and it would, the setup just happens to be the same for this one. 80 is opposite side B, and then again I would probably use 20 and 60 because that's my given set, but because that's the same angle, you're going to get the same answer, 172.8. And then that's everything. Okay. Mm-hmm.
Can we not solve for B and then just write like isosceles?
Yeah, sure. Probably won't be isosceles tomorrow, but if that happens,
Should be.
sure. Yeah. Okay. Other questions on this one? All right, next one. Solve triangle ABC, where A is 30, little a is 40, and little b is 70. I'm going to draw a sketch. A, B, C. 30. Opposite angle A is 40. Be careful with how you label it. If you label it wrong, you're going to be in trouble. And then opposite angle B is 70. Okay, so we're solving, finding everything that's missing. So let's figure out, do I have any pairs of opposites? Yes. What's a pair of opposites? 30 and 40, okay. Then one of 2 things should happen. Either number 1, you have a second pair of opposites, or number 2, you have 2 additional known side lengths. I don't have 2 other side lengths here, so I need to use another pair of opposites. 70 is the only other number I have. It's opposite B. 2 pairs of opposites means what law am I using? Law of sines again. So sine B over 70 equals sine 30, bless you, over 40, and then we cross multiply. So 7 sine 30 equals 40 sine B. And then we're going to divide by 40, which now is where you would use your calculator. So 7 sine 30 divided by 40, you get 0.875 equals sine B. And then how do you get rid of the sine in front of the B? Inverse sine on both sides. And you're going to get, I'm just going to round to the nearest degree, 61 degrees. Okay. Before I go any further, this is your special case, and this is one thing that a lot of people missed on that quiz we did over law of sines and cosines. So when you are using the law of sines to solve for an angle is when you could potentially have more than one triangle. So once we have our first angle, how do we figure out if the second angle will create another triangle? What do we do to get that second angle?
180 minus 61.
Yep, 180. So you're finding the supplement of it. It's called the supplements theorem if you look back in your notes. And if I do 180 minus 61, I'm going to get 119. Okay, so now the question becomes, if I took the 61 out and I put 119 in its place, would I be able to create a triangle with that? Yes, because I'm still under 180 degrees total. Between 119 and 30, that only gives me 149 degrees. So because I could use that instead of 61, we have a second triangle. I'm going to draw that second triangle. It's going to start by looking like exactly like that same set of information we started with. 30 degrees is A, 40 is A, 70. But this time, instead of 61, I'm going to put 119 in for B. Okay. And now we want to complete both triangles. In both triangles, what's the next easiest thing to solve for? Angle C. So you can just do 180 minus the two that you have. So for the top triangle, 180 minus 61 minus 30 gives me 89. For the bottom triangle, 180 minus 30 minus 119 gives me 31. And then the last thing we need to find in both triangles is side C. Now for side C, you can use the law of sines or the law of cosines. I think law of sines is going to be probably just as easy for this one. When you use law of sines to solve for a side length, you don't have any special cases. You don't ever have any special cases with the law of cosines, but it's just a little longer, so I'm going to use law of sines. All right, so for both of those then, let's say for the top triangle, I'm going to use my given pair, the 30 and the 40. And then I'm going to use the C's, so 89 and C. And then for the bottom triangle, it's going to look similar, sine 30 over 40, but this time it'll be sine 31 over C. And then we cross multiply in both of those to get that last side length. So for the top one, 40 sine 89 divided by sine 30 gives me 79.987, so I'm just going to say 80. And then for the bottom one, 40 sine 31 divided by sine 30, 41.2. And you can label those if you want. 80, 41.2. If you have a complete triangle, remember another thing you can kind of check at the end, make sure your answers are reasonable, is that the longest side is opposite the largest angle and the smallest side is opposite the smallest angle. That relationship should be true in all your triangles. Okay? Questions on that one? Great. All right, number 3, given a triangle with 3 sides, find angle B. You can draw the triangle here if you want to. Actually, I'll draw it out. Why not? But if you have side, 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 what law are you going to be using? It's going to be law of cosines. Yep, so B is 3.7. It doesn't look like 3.7. Let's try that again. 3.7. C is 5.4. And A is 2.5. Okay. Find angle B. So B and 3.7 are my one opposite pair, 2 additional known side lengths. When you use the law of cosines, your opposite pair should be on the extreme ends of your formula. So the B's are going to be on the far end. The side is always on the left. The angle is always with your cosine. The other two sides, it doesn't matter which one's which, that's the a and the b. So it's a squared plus b squared. So it kind of starts looking like the Pythagorean theorem at the beginning. But then minus 2 times a times b. That's a 2.5 there. Okay. All right, now we got to solve for b. So calculator work. 3.7 squared gives me 13.69. Then you can put the 5 and the 2 together there and square them. 5.4 squared plus 2.5 squared. 35.41. And then I can also multiply those terms together. 2 times 5.4 times 2.5 gives me 27 cosine b. So just a little simplifying on that first step. And then remember, we don't want to subtract those terms on the right because they're not like terms. So you want to start moving things over to the left side. So at this point, your next step is subtract 35.41. And that gives you negative 21.72 equals, make sure you bring down the negative 27 cosine b. Divide by negative 27. You're going to get 0.804 approximately is cosine b. And then last step, make sure you do inverse cosine. And to the nearest degree, it's 36.44. So I'm going to say 36 degrees. Okay. So let me squeeze that in there if I can. 36 degrees. Questions on that? Okay, so now for the second part of this question, it says find the area of this triangle. And you actually have two choices. There were two area formulas, and you could use either because you have an angle here. So the first option was this formula. I'll write both of them down here. 1/2 a, b, sine, c. The letters change, but pretty much for that one, you need two sides and the angle between them, which you have at the top of this triangle. The other one was called Heron's formula, and that was the one with the S. Do you guys remember what S stands for? Yeah, it's the semi-perimeter, half of the perimeter, which there's a formula for that too, but as long as you remember it's half the perimeter, you're fine. I'm going to use Heron's formula only because that would give me, or have me using just my given information. So let's say I got my angle wrong in the first part, maybe I made a mistake with my law of cosines. If I use Heron's formula, I'm only using given information, so I know at least this part will be right. So you can find these two pieces independently. But you can see with the other formula too, if you want to try it, you get the same answer or close to it because of rounding. All right, so let's do semi-perimeter. So that's half of all the sides added up, 5.4 plus 3.7 plus 2.5. So 5.4 plus 3.7 plus 2.5 gives me 5.8. Okay. So then my area, big square root, 5.8, and then 5.8 minus each side. 5.4, 2.5, 3.7, doesn't matter what order you do these in. Now with the red calculator, if you want, guys, you can type it all in first and then do the square root as like a second step if you want to. If you feel like, I know it's kind of hard to see what's on your screen in those red calculators, or you can do it all at once. So let's see what we get. It's about 4.01. And then I don't have a unit here, so we'll just say unit squared, whatever that is. Okay. Questions on 3? Okay. Number 4, maybe. There it goes. Again, an area problem. So I know it's a little tiny there. So it says 36 on the bottom left, 68 on the bottom right, and then I have a side length of 12. Do I have enough information right now to find the area? Do I have either 3 sides or side angle side? No. So we have to use law of sines or law of cosines to find something else. So 36 and 12 are one pair of opposites. Am I going to be able to use a second pair of opposites or 2 additional sides is what I need to think about with law of sines, law of cosines. I don't have 2 additional sides, so I'm going to be using law of sines and solving for b first. That's really my only option. All right, so sine 36 over 12 equals sine 68 over b, and then we cross multiply. 12 sine 68, and then divide by sine 36. And I'm going to give this a few decimal places only because this isn't my final answer, and I don't want to round it too much because that can make my area off by quite a bit. So 18.929 is B. Okay, now do I have enough information? 3 sides or side angle side? No. So what else can I solve for here? Angle C you can get pretty quickly, just 180 minus the 2 that you have. So 180 minus 36 minus 68 gives me 76 degrees. And now that top corner of your triangle, you have side angle side. So that's enough now to use the area formula with the 1/2 in it. So it would look like the following: 1/2, both of your side lengths, 12, 18.929, and then sine of the angle between them. And then you can just type the whole thing in your calculator. I'm going to get 110.20. Again, we'll just say units squared. Questions on 4? All right. Number 5 will be a word problem. So it's going to be a triangle problem. So when in doubt, draw a triangle. But that's going to probably be the toughest part of this one, is just getting it set up, making sure your picture looks right, and then using, whatever law is appropriate to solve it. So this one says 2 hikers, Sonia and Tony, leave the same point at the same time. Sonia walks east at a rate of 3 miles per hour, and Tony walks 45 degrees northeast at a rate of 4.3 miles per hour. How far apart are the hikers after 3 hours? Okay, so let's say, just pick an arbitrary starting point. There we go. Sonia walks east, which in our picture would be to the right. Okay, so we'll put a little S for Sonia's path. And then Tony walks northeast, that direction. Okay, now she walks directly east, so that's a horizontal line there. And she is walking at a rate of 3 miles per hour, and she walks for 3 hours. So if you walk 3 miles per hour for 3 hours, how far have you walked? 9. Okay, so the side of that triangle is going to be 9. That's her distance. Okay, he is walking 4.3 miles per hour for 3 hours. So how far has he walked? Multiply them, 12.9. Okay, so that's another side of my triangle. Now, when you are given a direction like northeast, that means from the north to the east is 45 degrees. Okay, so can you tell me what the angle inside the triangle is going to be? Also 45 degrees, because she was walking directly east, and that blue line I drew is directly north, so we can assume a 90-degree angle there. Okay. And our job is to figure out how far apart are the hikers. X. All right, what law are we using? Sines or cosines? This is going to be law of cosines. I have one pair of opposites, my 45 degrees of my x, and I have 2 other side lengths. X is by itself this time, 12.9 squared plus 9 squared minus 2 times 12.9 times 9 times cosine 45. This is the easier version of law of cosines. You're just going to be able to put that whole right side in your calculator. I'm going to get x squared equals about 83.2. And then in your calculator, just don't forget to take the square root of that at the end. So we're going to give it about 9.1. And this problem I would label miles, is how far apart they are after that 3 hours. Okay. Questions on 5. All right. The last 2 problems on here are just a couple of the basic problems that we saw with our exact values and our unit circles, those trig equations. What I would say about these 2 is just be really careful reading the instructions, okay? We saw a lot of instructions about sometimes we wanted all solutions, sometimes we wanted solutions on a certain interval, sometimes we want radians, sometimes we want degrees, so don't lose points for silly things like that. In this problem, it says all solutions, not a certain interval, and we want to give our answer in radians, so just make sure you're making note of that. Okay, the secant is already alone, which is great. Usually we don't look for secant in our unit circle though, right? What's the reciprocal of secant? Cosine. We use the reciprocal identity. And can you tell what number has been flipped to get this the secant? It's negative rad 3 over 2. And if you're not sure, you can kind of like test that yourself. If I found the reciprocal of that, it would be negative 2 over rad 3. And then if I rationalize it, we get negative 2 rad 3 over 3, okay, which is where that secant's coming from. You could also just take the reciprocal of the secant that you have there, so write it as 3 over 2 rad 3, and then rationalize and then reduce. If you don't see it, it just takes a few extra steps. And they're going to be unit circle values, so there's not a whole lot of options. Okay, where on your unit circle, there should be 2 of them, does cosine equal negative rad 3 over 2 in radians? What over 6? 5 pi over 6 is one of them. And there's one more. 7 pi over 6 is the other. Now, because it said all solutions, what do I have to attach to these? Plus 2 pi k. And we always use 2 pi except for what 2 functions? Tangent, cotangent. What would I use instead? Just pi k. And then one time somewhere on your paper, what do you need to write about k? K is an integer. Okay, good. All right, last one, very similar. Find all solutions between 0 and 2 pi. What are you going to do first? Subtract the 5. So we're trying to get that cosecant. Oops. Alone. So that gives me 4. Then what? Divide by 3. So that gives me 4 thirds. Then what? Get rid of the square root. And when you square root something, what should you put in front of it? Plus or minus. When you square root a fraction, square root the numerator, square root the denominator. Square root of 4 on top gives me 2. Square root of the denominator gives me rad 3. And you can rationalize if you want, but I wouldn't, because my next step is I'm going to flip that anyway. Instead of cosecant, I'm going to make it what? Sine. Plus or minus rad 3 over 2. And we want answers between 0 and 2 pi. So just on that interval, so no k's and radians here. And because it's plus or minus, there should be 4 answers. There's going to be 1 in every quadrant. Any place where sine is positive or negative, rad 3 over 2. So where in quadrant 1 does that happen? Pi over 3. Okay. And then once you get one of them, they're the same one, the ones that have the same reference angle. So you're going to see it's 2 pi over 3, 4 pi over 3, 5 pi over 3. And these equation ones, you can plug back in and check, make sure they work. Your calculator just has to be in radian mode for these ones. All right, so you'll see law of sines, law of cosines, couple little mini equations, and a bonus tomorrow. I'll be here at 7 a.m. if you need me. Otherwise, just make sure your 6-6 Math XL is finished tonight is a deadline for that, and then you can study with the resources on Polaris that you have. Yes. Go back a slide. Absolutely. There you go. Any other questions for me? Part 1 of our test. Okay, part 2 on there we're going to do together on Monday, so you could always, this weekend, you won't have any homework. If you want to try those problems ahead of time on your own before we go through them together in class, you've got them.